Alright, now let's just look into this particular question and see what are we supposed to do up here. So it says that we have a geometric sequence whose first term is u1 is equal to 1 and the common ratio is given as the 10, right? Now we know that the formula of Sn of a geometric sequence, because that's a geometric sequence and it's given in the formula booklet. So this is given as u1 into r to the power of n minus 1 divided by r minus 1. Alright, now we have the first term with us, which is given as 1. The common ratio is given as 10 to the power of n, and then minus of 1 divided by the 10 minus 1. So we end up getting the Sn as 10 to the power of n minus a 1 divided by a 9. So this is what our Sn will look like, right? So yeah, that's what the part A is. So if we want to know, like, that is more than enough, but for your information, A is equal to 10, right? And B is equal to 9, and it's written up here because it's the positive integer. By the way guys, I'm telling you, if in exam the conditions like this would become sometime really important, so you need to focus on these small details because they actually help a lot, right? Now that's the part A, and in part B, now let's just see how can we do this one. So we have S1 plus S2 plus S3 up to so on Sn is equal to this. We just need to show that, right? So we have S1 plus S2 plus S3 up to so on Sn is equal to 10 into 10 to the power of n minus a 1 minus 9n divided by the 81. So this is what we need to show. So what we can do is we can actually try with this particular general equation that we find out. So I'll just be substituting 1 into this equation, and what I end up getting is I'll end up getting 10 to the power of 1 minus 1 divided by a 9, and then I get 10 to the power of 2 minus 1 divided by a 9, and then 10 to the power of 3 minus 1 divided by a 9. And similarly, if I move until the Sn, so this becomes 10 to the power of n minus a 1 divided by a 9, right? Now see, our end goal is to get to this particular solution, right? And we just need to look into this equation and see if there is something that we can derive out of it, right? So the way I can look into this is, it is 10 minus that's 10 plus 10 to the power of 2 plus 10 to the power of 3 up to so on 10 to the power of n. And if you look over here, that's minus 1, that's minus 1, that's minus 1. So I can write that as a negative n. Alright. Whereas if I look over here, this, all of this can be written as a one single number. So I'll write that as the 9, right? Now in the next step, what I'll do is I'll try to take 10 as common from this one. So I end up getting 1 plus 10 to the power of 1 plus 10 to the power of 2 up to so on 10 to the power of n minus 1, and obviously negative n is over here, and divided by a 9, right? So if I look into the equation that I got in the middle, like this one, and let's just see that if I have a very similar thing with me earlier as well. So now let's just look for that, because I do have something very similar to this one in the previous situation as well. So we know that it is equal to 10 to the power of n minus 1 divided by a 9, right? So I'll be substituting that up here. It becomes 10 into 10 to the power of n minus 1 divided by a 9, and obviously minus n divided by a whole 9, right? So what I'll end up getting is I'll just multiply this with 10 and 10 to the power of n minus 1. Now because 9 is up here, so I'll try to make the denominator as same, so this becomes minus 9n divided by 9, and overall that's divided by a 9 as well. So I end up getting 10 times of 10 to the power of n minus 1 and minus 9n divided by an 81. So this is what I wanted to show, and I have successfully achieved my goal. So yeah, this is going to be the solution for this particular case.